Let's take a look at this lab that you guys completed on Friday last week, or at least started on Friday last week. Now, this should be a pretty straightforward lab as far as pendulums go. Okay, frequency and period both describe the motion of a vibration, right? Frequency is how often it occurs, or cycles per second, and period is how long it takes per cycle, or seconds per cycle. They're inverses of each other. Remember, the equation for calculating the frequency and period of a pendulum is very, very similar to that of the frequency and period of a mass vibrating on the end of a spring. We have T equals 2 pi times the square root of L over G. And if we look at this, we can see if the length gets longer, then T is going to get bigger. The longer the pendulum, the slower it goes. And frequency, being the inverse of period, is exactly the inverse of that. So 1 over 2 pi times the square root of G over L. Okay, and from that we can see as the length gets longer, this whole fraction gets smaller, which means the frequency is less. It occurs less often. If a clock is running slow, how should the pendulum be changed? Well, if it's slow, we want it to go faster. That means the pendulum should be made shorter. Okay, shorter slows it down. All right, now, or frequency or decreases. Okay, or if you'd like, period increases. Alright, then you guys went ahead and collected data, which was the video of the pendulum, and hopefully you got a graph that looked like a sine wave, and that was a horrible sine wave, but you get the idea. And what I want you to do is, you had minimums and maximums, and so I picked a time interval between maximums, and so use the graph to determine the period of the pendulum. Well, period T is seconds per cycle. So if you take this time interval right here, I'm going to call it delta t, and divide it by 2 cycles. Okay, so time delta t divided by complete cycles gives me my period. Okay, and from that you can determine the length of the pendulum, because t equals 2 pi times the square root of L over G. We can say, okay, well, if we divide both sides by 2 pi, t divided by 2 pi, and then square that, that equals L over G, and then multiply both sides by G, so G times t squared over 4 pi squared, right, I just distributed my square, equals L. Alright. This clock runs slightly fast. Every 7 days it gains 3 minutes. How should the pendulum be changed? Well, if it's fast, we want slow. Okay, and to make it slower, that means we want a longer pendulum. Okay, now, question number 4 is not a trivial question. Question number 4 takes a little bit of thinking. Actually, it takes quite a lot of thinking. It's not hard, it's just funny to wrap your head around it. Okay, the way I worked this problem is I said, okay, this clock runs fast. Every 7 days it gains 3 minutes. In 7 days, it gains 3 minutes. Now, here's how I did this. Okay, I said, well, let's think about how this pendulum works. The pendulum drives the minute hand. Okay, so every time the pendulum swings back and forth, the minute hand moves around the clock. Okay, and what we should see is in 7 days, the minute hand makes it makes 1 revolution per hour, and there's 24 hours per day, so 24 times 7 revolutions, or at least that's what it should make. Okay, and 7 times 4 is 28, and so 7 times 2 is 14. That's 168 revolutions per week. Okay, that's what it should make. So I'm going to write that over here. Should be 168 revs of the minute hand in 1 week. Okay? What we actually have is a little bit different. Okay? What we actually have is it's 3 minutes fast. Okay? In 1 week it's 3 minutes fast. Well, 3 minutes of 60 minutes is how much of a rotation? 3 over 60 is 1/20th, and 1/20th is 0.05. Okay, so we actually get 168.05 revolutions per week. Now, this is where the math gets a little bit funky. Okay? What we want to do is we want to change the pendulum so that we only get 168 revolutions per week. But each swing of the pendulum causes the same rotation of the hand. So we actually have to reduce the number of swings. Reduce number of swings. Okay? Well, how many swings is the pendulum making? Well, here's what we know about the pendulum. Okay? In 1 week, okay, the period is T. Okay, so 1 week is 24 hours per day, 7 days per week, 60 minutes per hour, 60 seconds per minute, and that gets us a really big number, 604,800 seconds in a week. 604,800 seconds. And we know the period is T, whatever you calculated up above. Okay, so that means each second divided by T gets me my swings. Okay, so this is where you've got to pay attention. What we actually have is 168.05 revolutions occurs in how many swings, right? I want revolutions per swing, so that's 604,800 divided by T. Okay? That's what I actually have. 168.05 revolutions happens in 1 week, and since 1 week is 604,800 seconds and the period is T, I know how many revolutions occur per swing. I don't want that many revolutions. What I want is 168. Whoop, I wanted that to change. What I want is 168 revolutions. Okay? I want 168 revolutions to happen per week. Okay? Now, a week is still 604,800 seconds, but I need a new period, so I'm going to call it T prime. Okay? Prime is a little apostrophe. Okay? So this is what I have, and this is what I want. Okay? So the ratio should stay the same. Revolutions per swing, revolutions per swing. Okay? This will allow me to calculate T prime. Alright, now, what first thing I want to do is I want to cross multiply. Okay, so I'm going to have 604,800 over T prime times 168.05 equals 168 times 604,800 over T. Now, this 604,800 is on both sides of the equation. It goes away. Okay? It cancels. That leaves me with 168.05 over T prime equals 168 over T. Okay? So I can cross multiply one more time. Cross, cross, and I get 168.05 T equals 168 T prime. Okay? Since I want to actually find T prime, what I have is divide by 168, divide by 168, and I see that T prime equals 168.05 divided by 168 times T. Now this right here is interesting. That's the percent wrong. Okay? It's not as a percent, it's as a decimal, but that's okay. Okay, so if you look at what I mean by that, I'm telling you this is actual measure, okay, the clock actually measured 168.05 revolutions divided by wanted measure. We wanted it to be 168 revolutions times the period. So if you look at that, we could have skipped a whole bunch of math if we just knew that equation. We could have just said, well, in a week it's this many minutes and it measured this many minutes. I'll show you what I mean in just a second. Okay. Right now I want to see how this is related to length. So if we take 168 divided by 168.05 divided by 168, you'll see that the difference here is incredibly small, right? This is not a very big error. 3 minutes in 1 week is not a lot of time. 168.05 divided by 168 is 1.000297. Okay, so T prime equals 1.00029, and I'm going to round, this is 298. Okay, now does this make sense? Well, we said the period needed to be longer. We wanted the whole thing to run slower. The frequency should be less. So yes, this makes sense, times T. Alright. Now the actual question wanted to know how much longer the pendulum should be. Oh, before I get into that, okay, I wanted to show you this. This said actual measured versus wanted measure. Okay. Well, if instead of using revolutions, which is how I did it because it made sense to me, if I did it in the time it measured, okay, well, it actually measured in 1 week 24 hours times 7 days times 60 is 1080 plus 3 minutes. So it actually measured 10083 minutes, but we only wanted it to measure 10080 minutes. Okay, and if we do that, okay, we get exactly the same number. Okay, this is 1.000298. Okay, so basically, I guess what I'm telling you is T prime, or the new period, is given by the old period times actual measure over wanted measure. Okay. Usually your wanted measure is going to be 24 hours or whatever. Okay, it depends on how the question is phrased. Alright, now the last thing to do is actually get this into length. Okay, since we know T, you can multiply, and so T prime equals 2 pi times the square root of L over G. Okay, which means you're going to take T prime, divide it by 2 pi, square it, multiply it by G, and get length. Okay? And so the interesting thing is you don't get to multiply L by this. What you really want to do is multiply L by the square of that. Okay? Anyways, hope that helps clear that one up a little bit. There is going to be a practice problem today that's very similar to that. Okay? Good luck with it. I hope you guys get it done.